Here we're going to talk about sequences and patterns and how to find the next number if they give you a sequence or a pattern. And so just know that there are more complicated problems, more complicated ways to do this, but I'm not going to show you those here. I'm just going to show you kind of the more simplified ways, and these are the things that I think they're going to ask you on the GED test. So if you go on to do, more higher level education, you might need to know more of the complicated ways regarding sequencing and patterns. But for the GED test, I'm going to show you what I think are the main things that they're going to test you on. So there's two basic concepts here. One's called arithmetic, and that's where you're going to add or subtract the same number to each item in the sequence. And then there's geometric, where you're going to multiply or divide by the same number. And then I'm also going to show you kind of a special case of square. And then we're going to talk about patterns. So we'll get started by just showing a possible problem here where they give you four numbers and then they say, what is the next number in this sequence? And the first thing that you want to do is first look, is it an arithmetic sequence? Meaning that they're adding the same number, adding or subtracting the same number to each item. So here, to go from 100 to 107, you add 7. To go from 107 to 114, you have to add 7. To go from 114 to 121, you have to add 7. So they're adding the same number each time. They're adding 7 to each number. So the next number, you would add 7 to 121. So the next number in the sequence is 128, according to the arithmetic sequence rule. We'll do another example. Let's say you had negative numbers, because it works the same if they give you, any type of number. Let's say they give you this and say, what is the next number in the sequence? Well, first, always start out, is it arithmetic? Are they adding or subtracting the same number? To go to 5, from negative 5 to negative 3, you have to add 2. To go from negative 3 to negative 1, add 2, negative 1 to positive 1, add 2, 1 to 3, add 2. So since they're adding the same number, we're just going to add 2, and you would get your answer of 5. Now similarly, let's say they say 9, 7, 5, 3. What's the next number? Well, here they're not adding, but they're subtracting 2. Subtracting 2 to go to 5 to 3, subtract 2. So we're going to subtract 2. 3 minus 2 is 1. So if you have an arithmetic sequence, all you do is look at it and say, okay, how am I getting from that number to the next number by either adding or subtracting? And if these numbers are all the same, then you have an arithmetic sequence, and you just do that to find the last one. But let's say we have something like 3, 12, 48, and then what? Well, we always again think, okay, is this arithmetic? To get from 3 to 12, we're going to add 9. To get from 12 to 48, though, we have to add 36. Well, 9 and 36 are not the same, so it's not an arithmetic sequence. So next we look, is it a geometric sequence? Are they just multiplying or dividing by the same number? Well, to get from 3 to 12, we have to multiply by 4. 3 times 4 is 12. To get from 12 to 48, you have to multiply by 4. 12 times 4 is 48. So, and these are the same, so we have a geometric sequence. So now all we do is multiply by 4. 48 times 4 is 192. So that would be the next number. Let's say we had 20, 10, and then 5. What's the next number? Again, I would always start, is this arithmetic? Well, to go from 20 to 10, we had to subtract 10. To go from 10 to 5, we had to subtract 5. Well, these aren't the same because remember in arithmetic it has to be adding or subtracting the same number. So it's not an arithmetic sequence. Now we check, is it geometric, where you multiply or divide by the same number. To go from 20 to 10, it's however your brain works. You can either say you're dividing by 2 or you're multiplying by 1/2. Those are the same thing, so however you like to think about it. So to get from 20 to 10, we divided by 2. To get from 10 to 5, well, you also have to divide by 2 or multiply by 1/2. Those are the same. So we have a geometric sequence. So now to get from 5 to the next number, you have to divide by 2 or multiply by 1/2. 5 divided by 2 is 2.5. So that would be the next number in the sequence. So that's how you check. Always check first, is it arithmetic? If it's not, is it geometric? Okay, I'm going to show you kind of one special case of squaring numbers because I've seen these on multiple practice tests. So you might be able to just identify it off the bat. So if you see something like this, you can say, okay, is it arithmetic? We add 3. Here we're adding 5, so no, it's not arithmetic. Is it geometric? Here we're multiplying by 4. To go to 4 to 9, I don't know what that is off the top of my head, but I know it's not 4, so it's not geometric. So now we start looking for patterns, but if you see this, just something to keep your mind on, is here what they're doing is squaring each number. So 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, so the next number would be 5 squared, or 25. So this is kind of just a special case that I just want you to keep in mind, that look, if it's 1, 4, 9, 16, think about, are they squaring the numbers like this? All right. Now, if it's not that special case, we're going to look at, if it's not arithmetic or geometric, we're going to see, is it showing a pattern? And in this piece, we're just going to have to think logically. So let's see, if we had 1, 3, 6, 10, what's the next number? So again, we always check, is it arithmetic? Well, to get from 1 to 3, you add 2. 3 to 6, you add 3. Well, those are not the same number, so it's not arithmetic. Is it geometric? To get from 1 to 3, you have to multiply by 3. From 3 to 6, though, you're multiplying by 2. And those are not the same number. So it's not geometric. And we can see it's not squaring 1, 2, 3, 4, 5, etc. So now we're going to look for a pattern, and you should probably start with addition or subtraction. So here, from going from 1 to 3, we're adding 2. To go from 3 to 6, you're adding 3. To go from 6 to 10, you're adding 4. So this is kind of a pattern, right? 2, 3, 4. So it would be logical that the next number you would add 5. And so 10 plus 5 is 15. So that would be the answer to that question. Let's look at 1, 2, 6, 24. What's the next number? Again, is it arithmetic? To get from 1 to 2, you add 1. To get from 2 to 6, you add 4. So that's not an arithmetic because these two are not the same. Is it geometric? 1 to 2, you multiply by 2, but 2 to 6, you're multiplying by 3. So it's not geometric. So now we think, okay, is it a pattern? And you start with addition, subtraction. 1 to 2, we added 1. 2 to 6, we added 4. 6 to 24, we added, what, 18? That doesn't look like a pattern. It doesn't jump out at me. So let's try, instead of addition or subtraction, let's try multiplication or division. To go from 1 to 2, you multiply by 2. To go from 2 to 6, you multiply by 3. To go from 6 to 24, you multiply by 4. Well, that's a pretty identifiable pattern. So we know to go to the next one, we're going to multiply by 5. And if we multiply by 5, the next one would be 120. Let's do another one where we have 5, 7, 11, 17, 25. What's the next number? So again, we're going to just say, is it arithmetic? We add 2 to get from 5 to 7. We add 4 to get from 7 to 11. It's not arithmetic. Is it geometric? To get to 5 to 7, I don't know that off the top of my head, but it's not the same as from 7 to 11. So I'm just going to say it's not geometric. So now I'm going to think, what is the pattern here? Go back to addition or subtraction. We had plus 2, plus 4 from 11 to 17 is plus 6. From 17 to 25 is plus 8. So this is a pattern if you think about it logically. 2, 4, 6, 8. So the next one would be plus 10. So 25 plus 10, your answer would be 35. Okay, I'm going to show you one more problem that is kind of a more challenging problem that I hope that you don't see on the test, but I just want to put it on the board here just in case you would run into it. It's something that you would see before. But I think what we've done thus far are the types of questions that you're actually going to see, but this will be something a little extra just in case. Again, here's our sequence. Is it arithmetic? We add 4 to 6, we add 2. 6 to 10, we add 4, so it's not arithmetic. Is it geometric? 4 to 6 is like multiplying by 1.5. 6 to 10, I don't know, it's like 1 2/3, so it's not geometric. So now we think, is there a pattern? We are going to first see, is there an addition pattern? Well, we already said 4 to 6 is plus 2, 6 to 10 is plus 4, 10 to 16 is plus 6. Ooh, we kind of think we have a pattern. But then, 16 to 26 is plus 10. So that kind of ruins it all. You know, and 26 to 42 is plus 16. So that's not an obvious pattern here. How about if we multiply? Again, we've already kind of determined this is going to be they're not going to give you that complicated of a question on GED to figure out this is 1.5, this is 1 2/3, this is 1 in whatever it is, 6/10. So what I want to tell you is I'm going to give you the answer on what they're doing. So if you run into something that you just completely can't figure out, one thing to think about, how they're getting this is they are adding the 2 previous numbers to get the third number. Add 2 previous numbers to get the third number. So 4 plus 6 is 10. 6 plus 10 is 16. 10 plus 16 is 26. 16 plus 26 is 42. 26 plus 42 would be what your answer is, which is 68. So they're taking the 2 previous numbers to get this number. 4 plus 6 is 10. 6 plus 10 is 16. 10 plus 16, 26, etc. And so to get this number, you're going to add these two numbers together to get the last number. Again, that was a little bit of a complicated question that I wouldn't expect, but just another kind of thing that maybe they would put that one on because it's not overly complicated as they could get. So that is sequences and patterns. Just remember, start by seeing if it's arithmetic, then if it's geometric. If you see the one that's a square, just try and recognize that, but then think logically about patterns.